Okay, today Lara will present her MSc thesis. Lara, you have approximately 30 minutes, okay?
Okay. This thesis, titled Forecasting Macroeconomic Series Using Advanced Econometric Models, is written under the supervision of Professor Tarantola and Professor Vrodos. So here is a short introduction of this presentation, an outline. So first, a brief introduction is done, then the dataset, the models, and the methodology used in the research are presented, and finally, the results and the conclusions are drawn. So among all the macroeconomic variables, this thesis focuses mainly on inflation. This was done in order to get a complete analysis. Moreover, this measure
Lara,
was
sorry to interrupt
highly
you.
debated.
We cannot see your slides. Or at least I'm not seeing your slides. I don't know if Dimitris and Yannis were seeing the slide, but I was seeing just a web page.
Just a web page, okay? I try to share again. Can you see it now?
Okay,
Yes,
now it's okay.
yes.
Now it's okay.
Okay. So here is the outline. And so among all the macroeconomic variables, the thesis focuses on inflation to get a complete analysis. Moreover, this measure was highly debated, and it is able to give an outline of the economic activity of a country. This is why we choose this variable. However, when we forecast macroeconomic variables and inflation, so including inflation, some issues may arise. The first one regards the difficulty of determining the superiority of a model over the others. This is because this assessment depends on other factors such as the data type, the data transformation, or the data frequency. The second issue that may arise regards the decision about the value to assign to the hyperparameters. And finally, we need to understand how many and which variables we should include in the models. All these issues are addressed towards the final aim of creating models for forecasting inflation and compare them. So now the data sets used in the thesis are presented. So a total of 9 data sets have been employed in the research. They are divided into 3 countries, which are Greece, Italy, and Germany. And for each of these countries, 3 data sets with different sizes have been employed. All the data have been downloaded from the Eurostat website, in particular from the Euro Indicators database, which is in turn divided into this subfolder, which refer to different economic activity and contain different indicators and indices. So the full dataset contains a total of 110 variables, and while the other 2 are subset of it. So the medium dataset contains pre-selected variables for a total of 57, while the last one, the small one, includes just 5 variables, and it is based on the macroeconomic theory. So these variables, which are included in the small dataset, are the inflation measure, the GDP, a variable that represents the consumer expectation, then the long-term government bond yields, and finally the unemployment rate. All the data are quarterly observed, and they were seasonal adjusted, and some transformation are employed in order to get stationary series. In particular, the inflation measure is the logarithm of the percentage change of the harmonized index of consumer price, and the log transformation is taken in order to get less volatile data. However, in all the 3 countries, we can see from the plot that starting from 2020, inflation raised. So now the models used in the research are presented. They are a total of 32, and the first 8 pertain to the autoregressive and vector autoregressive family. In particular, the benchmark model is an autoregressive model where future inflation depends on its past observation. Then the classical vector autoregressive model and its Bayesian counterpart have been used. In this case, we are not just forecasting inflation, but a vector YT that contains the 5 variables included in the small data set. And then some other Bayesian extension of the VAR model are included in the analysis. The first one is a time-varying parameter VAR model with stochastic volatility, where in this case also the coefficient B can change according to time. And then for version of a VAR model with fat-tailed and skewed distributed error.
Can I ask something? I'm not, let's say in the VAR model, you fit all 3 countries together. That's the point.
I didn't understand very well the question.
In the vector autoregressive model, you fit all 3 countries together. Okay. And
no. All the 32 model have been employed for each of the country. So all the data of each of the 3 countries have been analyzed separately from the others.
Okay, so can you help us on that? In the VAR model, what is Y?
Yes.
What is Y?
The Y is includes these 5 variables, but just for a country.
Okay, so you fit together all 5 variables. Okay.
Yes.
For each country.
Yes.
But you care about inflation. That's my. So the first model, the AR model, fits separately each one.
Yes, just inflation.
The 5 variables separately. Or the AR refers only to inflation.
When I employed the model to forecast, for forecasting, I forecasted just the inflation measure.
Okay. And this TVP VAR model, the only difference with the previous one is that your coefficients change over time, B1 up to BP.
Yes.
Okay.
Yes. And in this case, the coefficients are fixed, but the UT depends on this other.
Okay, you have a different assumption on the error distribution. Okay.
Yes, exactly.
Okay, let's go and we will see.
So actually, in the VAR system, you are interested in inflation only, but you use a kind of multivariate model. Okay.
Yes, to estimate the model, I use more variables than in the AR case. But when I forecast, I just forecast inflation. This is the difference. Then the next 8 models pertain again to the VAR family, but they were augmented with factors. So a 2-step approach is used in this case. In the first step, I used 2 different methods to extract the factors. And then once the factors were extracted, I used 2 different methods, representation actually, of a VAR model. The first one uses the factor to the extracted factors in the step 1 to augment the vector, while in the second method, the same factors are used just to augment the inflation measure. And then this formula represents just a classical VAR model. In this case, XT is a large data set.
Wait. But how far you go back in time? Because your model has only T. Should it be, let's say, that you are using previous factors and Y's? I mean, in the right-hand side of the equation, should it be FT minus something? Because it seems that you have FT
yes, it should
and
be
YT.
Here it should be T plus H.
Okay, that makes sense. Okay.
So is a large dataset from which the factors are extracted, and for this purpose, the full and the medium dataset have been used. So the last 16 models pertain to the shrinkage and machine learning family, but actually the first one is the classical multiple linear regression model, where the inflation is estimated using the 5 variables contained in the small dataset, except for the inflation measure. And then all the other models follow this general formula, where GH is a mapping function and depends on the employed model. So if we consider shrinkage methods, the ridge regression, the lasso, and the adaptive lasso are employed, while if we consider machine learning models, GH takes form of the artificial neural network, the support vector machine, and the random forest. So to estimate these last models, all the 3 sizes of the dataset have been used.
Is this of order 1 only? Are those models only of order 1?
Yes, in this case they are. In this case they are. So the methodology that have been employed is the expanding window setup. And the forecast horizon are the next trimester, semester, and year. So then a data-driven approach based on the root square error is used for selecting the hyperparameters, while the relative root mean square error that compares the root mean square error of the benchmark with the nth model is used to evaluate the forecast accuracy. So here is a short explanation of the expanding window setup. So suppose we are observing quarterly data for 3 years. Then I divided the sample in the following way. So I used the first 8 observation as training sample to estimate the model. And then the goal is to forecast, in this case, the first step ahead, so the 9th observation. So suppose also I am given a set of J hyperparameters, and then I predict the 9th observation using all the Jth hyperparameter. In this case, I end up with J estimates of the next step ahead, so in this case, the 9th observation. And then to select the best hyperparameter, I obtain a root square error measure comparing the observed value with the Jth predicted value. And then I select the hyperparameter based on the lowest RSE. So this is the case of the first iteration when we want to forecast the next trimester. At the second iteration, we include the 9th actual value into the training sample, and we repeat the process for the 9th observation. And we repeat all these steps until the last observation is forecasted. When instead we consider the forecast horizon equal to 2, so we try to forecast the next semester, we do the same process, but instead of forecasting the next step ahead, we forecast the 10th observation in this case. So then we include the 9th actual value into the training sample, and we predict the 11th, and so on. This is the approach used for the first 16 models, while for the machine learning and shrinkage methods, a similar approach has been used. So in the introduction, we saw some issues that arise. So, and here we can see the solution that have been employed in the thesis. So to determine the superiority of a model over the others, we compare the same models, but across different nations. In this case, we can understand if the same conclusions are drawn from across different countries. Then, in order to understand which value we should assign to the hyperparameters, a data-driven approach is used. In this case, in the thesis, when we say hyperparameters, we are referring to all those parameters that are selected before the estimation process begins, and not only to the Bayesian interpretation of this term. And finally, we use different datasets with different sizes in order to understand which variable we should include in the models. So in general, it's difficult to draw conclusions that are shared from all the 3 countries, but we have some. So generally, the VAR and the Bayesian counterpart outperform the benchmark, but it is not clear which one between the 2 is the best. Then, if we consider the vector autoregressive model with skewed and fat-tailed errors, it seems to perform the best compared to all the other models. And this conclusion is shared across different countries, all the countries, and across all the forecast horizon. And this may be because of the high volatility of the last year, but this needs further investigation. Instead, if we consider the vector autoregressive, it seems the best to produce them using the medium dataset, so using pre-selected variables, because we are more likely to obtain lower root mean square errors than the benchmark. And if we consider if we focus on the VAR representation, we should use the first representation, so the one that augments a vector with the factors. If instead we focus on the first step, so on the method with which the factors are extracted, we should use a full data set for a dynamic representation of this method, while we should use a dataset with pre-selected variables if we want to use a static representation. In my work, the shrinkage and the machine learning methods outperform the benchmark just in few cases, but this needs further investigation, because in this case we use just one lag. So when we consider shrinkage and machine learning techniques, I consider just one lag, because we had many hyperparameters to estimate. So it was very time demanding to calculate all the models with different lags also, while all the others all the other models are actually considered from 1 to 5 lags. So this may be the motivation why these methods, so the shrinkage and machine learning techniques, does not outperform the benchmark. Thank you for your time, and if you have questions, please ask me.